Yo, what is up, guys? My name is Sankarshan, and I will be teaching AP Statistics for Bizinstitution. Um, I'm about to enter my senior year. I took stats as a sophomore. Had a high A the whole year, got a 4 on the exam. And yeah, I'm just gonna be teaching y'all all the concepts. I'm gonna cover in each video 1 unit. So there's 9 units in total. I'll have 9 videos per unit, right? But at the end, my 10th video will be like calculator tips and tricks for stats because that is actually very important. Saves you a lot of time and energy on the exam. But I'm only putting it at the very end because it's important. It's actually crucial you understand the concepts before you try to cheat your way with the calculator, because you really need to know like what you're doing, because later on in stats it can get a little complicated and the calculator can help you out, but it can't really show you how to solve the problem, right? So yeah, that's how the course is going to work. And yeah, let's just get started with unit 1. So the first thing you learn in stats is variable types: categorical, quantitative, independent, and dependent. So categorical data is just anything that has a label to it, right? No numbers, just words. If you're talking about colors, names, ethnicity, right? If you're saying uh car brands, right? Like Toyota, Honda, Bugatti, these are all, there's no number involved, right? It's a label. Talking about people's names, right? Jack, Josh, Sarah, these are names, there's no numbers. Ethnicity, race, right? Black, white, Indian, wherever. What are you talking about? There's no numbers. That's categorical, right? It's pretty easy, pretty straightforward. Quantitative data is the other kind of data that has numbers. That's what you think of when you think about stats. You probably think of quantitative data, making all these calculations. It definitely is heavy in quantitative data, but it's important you understand the difference between quantitative and categorical. So quantitative is just, it'll be a number with a unit of measure, normally following that number. So weight and height, by the way, they show up a lot on the actual exam. So just be wary of that. And weight will be like what it's not like weight is someone's weight is it's not a word. Someone's race is a word, but someone's weight is a number, right? That's just the difference between categorical and quantitative. Weight, height, distance, these are all numbers followed by some unit of measure, as while categorical is just a word, it's just a label. I think you guys probably understand what I'm trying to get at here. It's not a very difficult concept. So yeah, let's move on to independent versus dependent. So before I talk about independent variables, I want to talk about dependence, because I find it much easier to identify independent variables after knowing what the dependent variable is. So a dependent variable, right, as when you're talking about experiments at least, right, it's what you're looking for. So if someone's having an experiment, right, and they're trying to, well, let's talk about this because one of the graphs in a later chapter actually talks about this. But say you're having an experiment to see how distracting different stimuli are for shooting free throws, right? You'll have someone shooting, the control group will be just the person shooting regular free throws, no distractions, right? And then you'll have stimuli, maybe a baby crying, maybe flashing lights, maybe an audience, right? What are you looking for? You're looking for how many free throws that person can make. That's what you're recording, right? After each stimuli, you're marking down, he made this many free throws after this stimuli. He made this many free throws after this stimuli. He made this many after this stimuli. So what you're recording, what you're looking for, the basis of the experiment, right? That's the dependent variable. So in that case, it's the number of free throws made, right? And now independent variable, right? Once you realize the connection between dependent and independent, it's very easy, right? Sometimes it can get tricky, but once you realize this concept, it's very simple, right? The independent variable is what is directly affecting the dependent variable. So after you identify the dependent variable, right, number of free throws made, it's just what is changing that number? What is causing the number of free throws made to change? Well, in this case, the independent variable is the stimuli the player is exposed to. That's what the independent variable is. And if maybe that doesn't make the most sense, I can explain it in like maybe a simpler concept would be if you're measuring like you can say the uh, height of someone in relationship to their age, right? So you're recording stuff down, you're recording the heights of different people. So the dependent variable is how tall they are, and the independent variable is their age. Like, independent variables don't change. They just happen, and they just move on. Time flows on its own. People age on their own. Those things are not affected by someone else. Even in the basketball experiment, being exposed, those players, regardless of what happened, would still be exposed to this stimuli. Regardless of what happened, they would still be exposed to that stimuli, right? The only thing that changes is what happens after the independent variable. Someone's age will affect the dependent variables of, like, maybe height and intelligence, right? The stimuli in the experiment of the basketball free throw experiment will affect the dependent variables of how many free throws are made. So that's like the relationship between independent and dependent variables. Maybe I went a little too much in this. It's really not that complicated. And if you graph data, right? If you imagine the letter L, the independent variables are graphed on the horizontal part of the L, so the x-axis of your graph, and dependent variables are graphed on the y-axis, so the vertical part of your L. So yeah, that's all you really need to know for chapter 1 of unit 1 of stats. Chapter 2 is displaying data. So like charts, graphs, diagrams, the whole lot. So first thing, bar charts. This is one of the most common forms of data, being displayed that you'll see. Not just in stats, but in real life, right? So here, this is what I was talking about with the experiment, the free throw experiment. So you have player A, player B, player C, right? They shot their free throws in the control, right? Player A seems to be really cold, right? 10 out of 10. And then B and C, they're not bad, right? 7 and 8 out of 10. Missed a couple, it happens. And then you run the experiment and you see the independent variable on the x-axis, right? Like I said right here, independent variables shown on x-axis, dependent shown on y-axis. So the independent variable is the stimuli, right? The stimuli is changing. And the dependent variable, the number of shots they made, is being counted on the left side. And the crucial thing about bar charts is that x-axis is categorical, right? Look at the bottom. It's words. It's not numbers, it's words. That's categorical, right? So that's something important about bar charts. And unlike histograms, which I'm about to go to after this, notice how there's gaps, right? It's not all like mushed together. No, there's gaps in between this thing to show different sets of data, right? Under different stimuli. So even if you took out player B and player C and say you're only looking at the blue lines and you're only looking at player A, it's still a bar chart that shows player A under different stimuli, right? 10 out of 10 in the control, 8 out of 10 when the baby's crying, 10 out of 10 in the audience, it didn't phase him, and then a 2 out of 10 when there's flashing lights. So that's how bar chart is basically read. You look at the categorical data, the x-axis on the bottom, you look at the bar, right? And then you see how high that bar goes. It goes to 10, that means he made 10 out of 10 shots. It goes to 2, that means he made 2 out of 10 shots, right? So yeah. And this I'm only saying 10 out of 10, 2 out of 10 because of that's just how it was, but the bar chart won't actually show that. I'm just saying 2 out of 10. He could have taken 15 shots and the most he made was 10, right? But that's the highest anyone made, so it only goes to 10. The bar chart doesn't have to go higher, right? So yeah, that's basically how you read a bar chart. And now we have histograms. Look, it looks a little similar to a bar chart, right? But it's not quite the same. You realize that pretty quickly. So the two things that separate a histogram from a bar chart are what's on the x-axis and whether there's gaps or not. Now I have two similar sets of data, right? Test scores on, students' test scores. So I have a bar chart for that data, and if you look at the bottom, it's categorical, right? Each bar, the bottom of it is a student, right? It's not a number, it's like a given student. That's categorical, right? But if you look at the bottom of the histogram, which is on the left, it's numbers, it's quantitative, right? And on the bar chart, there's gaps in between the bars, but in the histogram, there's no gaps. So essentially, right, they look similar, but a histogram shows you how often something occurred within a given range. So to make that more clear, if you look at the bottom of the histogram, right, on the left, 4 people, right, the frequency of the first bar is 4, but the base comes down to like it's in between two numbers, right? On the bar chart, the bar comes down to something right under it, student 1 or student 2 or student 7. But on the histogram, it doesn't come down to a specific thing. It's in between two values, right? So the way you read that is 4 people got a score between an 88 and a 91. And then 3 people got a score between a 91 and a 94. And then 3 people got a score between 94 and 97. 2 people got a score between a 97 and 100. And 2 people are tryhards. So that's just how you read a histogram, basically. So yeah, let's move on. Dot plots. Dot plots are pretty straightforward. This is something I feel like everyone has seen at some point in like maybe elementary school, right? But a dot plot is basically each dot representing, okay, so my bullet point says every dot represents an occurrence of its given category. So to make that more clear, basically, so say we're talking about number of shots made, right? Say everyone took 10 free throws and then you plotted it on a dot plot, right? Every dot, right? So say you look at 5. There's 3 dots above the number 5, right? So number of shots made, 5. There's 3 dots above 5 shots made. Every dot is an occurrence of its given category. So the given category is 5, right? Each dot is a person making 5 free throws or 5 shots. So one person, that dot above 8 represents one person making 8 shots. The 3 dots above 5 represent 3 people making 5 shots. And then 2 people made 4 shots. 4 people made 3 shots. And 2 people made 2 shots. And the second bullet point is dot value is consistent. So a dot cannot be like one dot is equal to 5 people and then another dot is equal to 3 and another one's equal to 2. No, it's all consistent. And normally there will be a key that'll say like key and then dot equal to maybe 1 or maybe 5, right? And then each dot is just equal to that. So if the dot value, if there's a key right here that said dot equal to 5, then that would mean 15 people made 5 shots. It's just the dot represents more in that case, more than one person, right? So that's how you read a dot plot. So now we're at stem and leaf diagrams. So stem and leaf, it can look a little intimidating and complex at first if you've never seen it before, but it's very similar to a dot plot actually. So the first thing you want to look for in a stem and leaf diagram is the key. The key will tell you like what you're actually looking at. So in this key you can see 6-5 is equal to 65%. So we're dealing with test scores. We're dealing with one really rough test. Yeah, the scores on this were really bad, right? So the way you can tell that is basically you connect the leaves to the stem. So look at the key, right? 6-5 is equal to 65. So the stem is like the tens place, right? And the leaf is the ones place, right? These are all whole numbers. So each leaf is one person. So if you like in your head, or if you actually want to move your head, tilt this stem and leaf to where the stem is the x-axis, it looks just like a dot plot, right? You have like a thing on the bottom and then it goes up, right? And then each number represents a person, right? So it's actually very similar to a dot plot, but here to make it a little like clear in case you guys are still lost, if we look at, let's look at the very top line, right? 0, 0, 2, 2, 3, 4, right? So on this test, one person got like no credit. They got a straight 0, Straight 0. The stem is 0 and the leaf is 0. You combine 0 with 0, that's a 0, right? So the tens place is a 0, right? So you move one to the right. One person on this test, well, more than one, but two people on this test got a 2. The tens place is a 0, and the ones place is a 2 for two people, because each of these numbers represents a different person, just like a dot plot, right? If you tilt this to where stem is the x-axis, each of these numbers is like a dot, right? But it's a little more specific than the dot, because instead of telling you this many people got this, it tells you the exact grade, right? And then you have to do the number of people that measure in your own head, right? So you can see 5 people got 35s, right? The key says 3-5 would mean 35%. And if that 5 showed up 5 times, then there's 5 instances where the tens place is a 3 and the ones place is a 5. Yeah, I mean, that's all there really is to stem and leaf. I don't really know if there's another way to explain it. It's just connecting the tens place with the ones place, and the key is crucial. You want to look at the key, know what you're talking about. So yeah, pie charts. This one is like really common. It's about as common as the bar chart. So pie chart just tells you what each category is out of the entire data set. So if you're looking at the letter grade in the class, right? 42 in this situation, 42.9% of people finish with an A, right? A third of them finish with a B. 14.3%, you know, they got through with the C, right? And then 9.5% had a rough year, right? So that's all a pie chart is. It's out of a whole what percent the different things were, right? It's the thing about a pie chart that makes it nice is it's like it looks nice and it like compares the values to each other, so you can see which data value made up the most out of your given data set, right? And the thing about a pie chart is these are percentages, right? So if you add a percent, right, say 42.9 becomes 43.9, then the other 3 categories would have to lose a percent combined, because everything is out of 100, right? That's just some basic understanding of percentages. I'm sure you guys already have, so we can probably move on to box plots. Now, box plots, if you've never seen them before, they definitely can look a little confusing, and they do show a lot of information. So you might be a little confused, but all you need to know for now, because we do go into the concepts that a box plot displays later on. So for now, all you just need to know is that a box plot breaks up quadrants, or breaks up a data set into 4 quadrants. So you know, I'm gonna explain all this later, but like just for now I'll say that like between the lower whisker and lower quartile is a fourth of the data set, and then between lower quartile and median is another 1/4 of the data set, and then between median and upper quartile is another 25% of the data set, and between upper quartile and upper whisker is another 25% of the data set, right? Excluding outliers. So that's all it is. Like fitness gram pacer test, like you can see this is one very unathletic class. The middle score, the median, which we cover later, right? Median is just a middle score, was 6, right? And then 50% of that class got less than a 6, because the box plot splits it up into quartiles, right? And 2 of those quartiles are to the left of the median, and 2 of them are to the right of the median. So half the class got less than a 6 on the fitness gram. So that's basically how you read a box plot. And we'll go into more detail later on. All these concepts will become a little more clear, so don't worry if you're a little confused for now. So chapter 3, describing data. So whenever you know, this is going to come up on the stats exam. You're going to be asked to describe data, right? You're going to get maybe a graph or a chart, and it's going to ask you, describe this, right? So you absolutely need to cuss. You must cuss, or you're not getting all the credit, have to cuss. Remember that. You have to cuss. You just have to. You have to mention the center, any unusual features, spread, and shape. If you don't do that, you're not getting the full credit on your FRQ. It's very important. Alright? And now these things in parentheses that I have, I go into them in detail later, so if you don't know what any of them means, don't worry. The only thing I don't cover after this is under shape, you see unimodal or bimodal. And that's just if you see like a curve, right, or a distribution of data, if it like goes up and comes down once, it's unimodal. It has one peak. Uni means one, unimodal, it's one peak. If it happens twice, right, goes up, comes down, goes up, comes down, right, that's bimodal. It has two peaks. Bi means two, and that's literally all it is. And then all the other things, skew, range, SD, outliers, gaps, mean, median. I'll go over all of that later on. So that's that. So skew. What is skew? So sometimes when you plot data, right, it's not going to be symmetric. Say you're talking about like test scores. I guess test scores again, right? And you have like a high amount of like high grades, but it's not equal. So you find the mode, right? You find the mode, and it's not equal to the left side and the right side of the mode. The mode is the data value that occurs the most. So if you're talking about test scores, right, you find that a 97 occurred the most frequently. Now, when you plot all the test scores of the class, right, if it's not symmetrical, right, if the left side of that 97 and the right side to the 97 don't look the same, there's skew, right? And right here, I drew out the different kinds of skew. So the top shows left skew, and I don't know, the way I think about it, the way I couldn't like think about skew in my head is like, I think of like if you take a stick, right, and you have like Play-Doh, right, like a little Play-Doh mound, and you take a stick or something, and it's like bendy Play-Doh, right? It doesn't crumble, it's like it'll bend. And you take a stick, right, and you drive it from the right through the thing, right, and going in the left direction, then the mold of that thing will look like left skew. So whatever's in the top, right? If I took a stick and went through that mound, I'm gonna stretch the left end of it a little bit, right? And because I'm driving the skewer in the left direction, that's left skew. And the opposite of that is right skew, right? That's just my idea of thinking of it. There, you can definitely like, there's other ways to think of it, but that's just how I think of left skew and right skew. But a concept you should know is, well, mode is gonna be the peak of that distribution, right? Mode is the thing that occurs the most frequently. So that's going to be the top, the highest point. And because it's not symmetrical, it's going to like come down in like a little uneven way. So if there's left skew, then the median is going to be higher than the mean, right? I'll cover these concepts like right after this. And if there's right skew, then the mean is going to be greater than the median. So mode, median, mean, right? I've mentioned all of these. What exactly are they? The three M's, right? So mean just means average. You add up all the data values, divide by the number of data values, that's your average. The median is the middle value of the data when ordered from least to greatest. Now that's very important, right? Sometimes you get data, right, and it's just going to be jumbled up, right? Numbers here and there. To get the median, you have to rearrange it from least to greatest and then start crossing stuff out from both sides to get to the middle. Because if you don't rearrange it, then you're not going to get the median. You might, but it'll be pure luck, right? You have to rearrange it first. And then mode, whichever value occurs most frequently. So we can see these concepts in this data set I have right here, right? So let's see. We'll start with the easiest, go to the hardest. So mode, easiest one to find. Which one occurs the most, right? Well, all of these data values occur once, except for 8 and 15. 8 shows up twice, 15 shows up 3 times, 3 is greater than 2. 15 shows up the most times, so the mode is 15. So if we're talking about, like, you know how we're talking about the curves? The mode would be 15 in these. if we're using like a data set that's skewed. The mode would be the thing that shows up the most, right? So the peak, like if you're imagining this to show the data I have right here, then the peak would be at 15 because 15 shows up the most, right? 3 times. So that's mode. And then median is, so I already rearranged the values in order from least to greatest just to make it easier for myself. So the median is 13, and you might be like, I don't see it 13, right? Where are you getting this 13 from? So the thing is, when you have a data set that is an odd number, right, then it'll be very straightforward. You cancel out numbers and you'll be left with one single number in the middle. The numbers, all the numbers to the right is the same amount as all the numbers to the left of that number. But when you have an even set of numbers, right, and you're crossing out left and right, right, then you get down to two numbers that are right next to each other. And you know, don't do this where you like, oh, I was crossing out, say your crossing out pattern is left and then right, and you get to the two numbers in the middle and you cross out the left one and you're left with one. No, that is not how you get the median. What you do when you have two numbers left, right, next to each other, you're just finding the middle value of the data set, right? So you find the number in between those two numbers. So you just add up those two middle numbers and divide by 2. In this data set, it's 12 and 14. You're left with those two next to each other, right? Because there's 4 numbers to the left of them and 4 numbers to the right of them. So 14 plus 12 divided by 2 is 13. So that's your median. And mean is just, you add all these numbers up, divide by the number of, divide by how many numbers there were, right? So you add up 5 plus 16 plus 10 plus 12 plus 14 plus 15 times 3 plus 18. You get 120. And then you divide by 10 because there were 10 numbers to get your mean of 12. So that's the 3 M's: mean, median, and mode. Now measures of spread. So what exactly is spread? Within a data set, right? If you are talking about, let's say you have class A, right? Class A is full of some really smart kids, right? And then class B is a class like, it's mixed. It's more mixed, right? You have some really smart kids, some tryhards, some average intelligence, some kids who are struggling, right? So class A is the smart kid, right? All kids in there are really smart, right? And you give both of them a test. You give both of them a test, right? And you get, you plot out, oh, this is the test scores, right? When you plot out the scores for both classes, right? The spread of class B will probably be much higher than the spread of class A's. Class A is just full of smart kids, right? They take the test. They all get high grades, right? Say the average grade maybe like a 97, right? The lowest grade probably like a 95, right? Highest grade probably 100, right? So there's not that much spread. It doesn't vary that much, right? It's all within the same like 5 values. Everyone got a score somewhere up there, right? But you look at class B, way more spread, right? Like some kid could have got 100, some kid could have got a 0, right? Like there's way more, like if you were to randomly pick out a score, you're picking from anything of 100 different values, right? For spread in class B. It's way more, the spread is way greater. But if you're picking a random value from the class A, it's just going to be one of these 5 numbers, right? There's not that much spread. So that's essentially what spread is. And spread will decide how wide your curve looks. If your curve is plotted, it goes like up really high and then comes down. There's not that much spread because most of the data values are within a very short range. So it just goes very high. But if there's like class B, there's a wide range, that means it's not going to go that high because there wasn't probably a large number that got within a certain range. It was more spread out, so it's going to be wider and shorter. So class A's curve would be like higher and thinner, and class B's would be more like stumpy, right? Shorter and wide. So that's like essentially spread and like recognizing it, right? So these 3 things are big measures of spread, right? Range, variance, and standard deviation. So range is like the scope of data, right? At the bottom, you have these 6 data values, right? Let's say you're talking about the age of lions in a safari, right? So you take the highest, right? The oldest lion is 69 years old, right? The youngest lion is 32 years old. If you do 69 minus 32, you get 37. So there's a difference of about 37 years between all these lions. All these lions, their ages fall between a range of 37 years. So that's all ranges, right? It's just the highest value minus the lowest value. And it's a decent indicator of spread, you know. It tells you if you have a high range, that means like class B would have a high range. 100 minus 0 is 0. I mean, my bad, 100 minus 0 is 100. So the range is really great. But class A, 100 minus 95 is just 5. There's like no, the scope is not, it's not that, the spread is not that high. So range is still a decent measure of spread, right? And then you have variance. Now variance can get a little complicated, right? It's definitely a pain. I'm not even gonna lie, it's a bit of a pain to calculate, right? There's a lot of like individual things you have to do. But from variance, you can get standard deviation, which is very useful. It's a very good measure of spread. If you can mention it in your FRQ, then try to mention it. It's a very good measure of spread. And it shows you have a good understanding of spread as well. So to get variance, first you get the mean, right? So variance is telling you like how spread the data is from the mean, right? But it's not like it's not in the number, it's not going to be a number that you're actually comfortable with, because it's going to be like the squared of the number that you actually want. Basically what I'm trying to say is when you find variance, right? Look, okay, we'll just look at the numbers at the bottom and you can maybe get a better idea what I'm talking about. So the variance of these 6 lines, right? 177.2. Now, like, what could that number even possibly mean, right? So variance is like the main reason you would even use variance is so you can get standard deviation, right? 13.31. Now, standard deviation tells you on average how far away were the data points from the mean. So the lions were on average about 13 years, you know, older or younger than the mean, that the middle age, the average, right? So that's a very good indicator, right, of spread. If you have a high standard deviation, that means there was a lot of spread. That on average, the data points were far from the mean, right? But if you have a small standard deviation, they were closer to the mean. On average, they were not that far from the mean. So that's standard deviation. That's easy to understand. It makes sense. But variance, you just need to know how to calculate it, because from it you can get standard deviation. But actual variance itself, it's mainly used for more higher mathematical like calculations. But what you do is you calculate the mean, right? So for the lions, you would add up these 6 numbers, divide by 6, right? You get the mean. Now you find each score's deviation from the mean, square that, and sum them. So I did the calculations on a sketchpad, but if I alt tab out, then it's gonna stop recording. So let's just say the mean is like some number in here. Let's just say the mean is like 47 or something, right? It's not. It's probably not 47. But to do steps 2 and 3, you would do 32 minus, and I'm just saying the mean is 47. It's probably not 47. I'm just saying that so you know how to do steps 2 and 3. So you would do 32 minus 47, right? The deviation squared, and then you would do plus 41 minus 47 squared, plus 46 minus 47 squared, plus 52 minus 47 squared, plus 60 minus 47 squared, plus 69 minus 47 squared, right? By doing the data point minus mean, you're seeing how far away it is, and then you're just squaring it and adding all that up, right? And then you divide that by either the number of numbers you have or one less than that. So if we're dealing with, say, these lions you're talking about, right, their ages, if they're just a sample, we're gonna say they're a sample, right? Because the whole safari would have more than 6 lions. So this is just a sample, right? But if we're dealing with the entire population, right, then we would divide by 6. If the entire safari only had 6 lions, these 6 lions, then we would divide by 6. But because it's just a sample, we're dividing by 6 minus 1, so we're dividing by 5. So we would divide that number after step 3, which we get, by 5. And that's the variance of 177.2, right? It looks a little bit complicated, but all you're doing is taking your data, you find the mean, find the difference between the mean, between your data point and the mean, right? If it's less than the mean, that number will be negative. If it's greater than the mean, that number will be positive. Square all those, and then add them up, and then divide by n, right? Or n minus 1, depending on if it's a population or sample. So that's how you get variance. So in our case, it's, the variance is correct though. I know the variance is right because I did the calculation. 177.2. And then standard deviation, which I mentioned earlier, which is a very good indicator of spread, is just the square root of the variance. It's about 13.31. And that just tells you on average how far the data is from the mean. So it's a very good indicator. Like I mentioned earlier, the lions are about 13 years older or less than the average age. So now we have IQR. Remember I said, oh, we'll get into box plots later. This is the later. Where this IQR is the main concept that box plots, revolve around and really work with. So IQR is interquartile range. Remember how I said a box plot splits data into 4 quadrants? Well, the IQR is that blue box you see. It's the middle 50%, right? It's the upper quartile, the third quadrant, minus the first quadrant. So it's Q3 minus Q1. So Q1 is a 25th percentile. You see the left edge of the box is Q1. Everything to the left is 25% of the data. So it's in the 25th percentile. Q3, the right edge of the box, is the 75th percentile because there's 3/1/4 of the data to the left. 25% 3 times to the left of Q3. So that's 75% of the data. Right, so the way you get Q1 and Q3 is, so first you find the median, right? We have the median is 6. You then have to split the data. So actually, let's go back to the lions here, right? You have 6 data points, right? So when you're finding the median, because these are already in order, right? So remember, to find the median, you just find the middle value. But because we have 6, then we're gonna have to find the middle of the 2 in the middle, right? So that value is at 49, right? It's in between. That's the middle value of the data set. Median is 49 for these lions, right? To calculate Q1, right? So 49 would be like right here. Q1 would be 41 because you just split the data, right? Split it. When you get the median, just split the data in 2 parts and then handle each left side and right side on its own. So you're dealing with these 3 for Q1 and these 3 for Q3. So then find the middle value of the left side. The middle value is 41. So Q1 would be 41. And the middle value of the right side is 60. So Q3 would be 60. So that's telling you that the 25th percentile of these lions' ages is 41. And the 75th percentile for these lions' ages is 60. So that's all Q3 and Q1 is, right? And now this is the most important part about knowing IQR. It's the outliers. So an outlier is something that is just very far off from the actual, like, most of the data, right? And to measure this statistically, right, to guarantee it is an outlier, you have to do the IQR times 1.5, right? So that's the first thing you have to do. So IQR is Q3 minus Q1, right? And then you have to multiply that by 1.5. And to find low outliers, you go to Q1 and you subtract that 1.5 times the IQR from there. Anything less than that, so this box plot excludes outliers. So anything less than 1 would be an outlier. Any fitness gram score less than 1 would be an outlier. And then for high outliers, you go to Q3, right? And Q3 plus 1.5 times the IQR. Anything more than that is a high outlier. Right here you can see there's that one athletic kid who just got way more than everybody else. right? He's an outlier. But that's how you use the concept of IQR, Q1, Q3 to find outliers and like really understand what a box plot is trying to tell you, right? So this box plot like doesn't show outliers. It shows you the range up until anything outside of it is an outlier. That's very useful, right? You don't have to do any calculations. You can just see. And then Q3, Q1, median, these all split the data into 25%. It's easy to see, like half the class got less than a 6, right? Half the class got between a 6 and a 15. And then that one kid, he got way more, right? Or he got more than 1.5 times IQR plus Q3, right? So that's the whole concept of IQR. And now this is almost, after this, there's one more thing. But z-score, this is very important, right? Z-score is something like you don't like forget this at any point, because this is going to keep showing up throughout the entire stats course. It's a very important concept. It's simple though, but it's a very important concept. So z-score tells you how many standard deviations away a data point is from the mean. So if you remember, standard deviation was how far on average the data is from the mean, right? So in the lion's case, it was 13 years. On average, the lions were 13 years older or less than the mean. So now the z-score is if you take a certain lion, how many standard deviations it is from the mean, right? So I don't know if that makes complete sense, but we can just calculate that and it'll make more sense, right? So let's do the practice. If the class average on the test was a 75, right? With a standard deviation of 3, so on average people varied from the 75 by 3 points, and you got an 83, what percentile are you in? So to get the percentile, you have to look at this chart and everything. So this might look a little complex first, but first let's just get the z-score, right? The z-score would be 83 minus 75, right? Your value, your test score is the data value we're looking at, minus the mean, right? The 75. And you divide that by the standard deviation, right? 83 minus 75, that divided by 3 gives you about 2.67, right? I'm rounding to 2.67 because it's just easier. And now the third bullet point, a z-score table displays the percentile of a data value based on its z-score. So percentile, right? What is percentile? Percentile is, well, first let's just calculate the percentile, and then I'll explain what a percentile is in terms of the situation, right? So what's the z-score? 2.67, right? So now we use the z-table to find the percentile from that z-score. So if you look on the left side, it's all negative values, right? The z is always less than 0. So we're not using the one on the left, we're using the one on the right because it's positive. So the z-table is actually really simple. It's just it goes to the tenths value, and then the top goes to the hundredths value. So then you just combine the two and you get your number. So we're looking for 2.67, right? So we go down to 2.6. And then now we go across till we're at 2.67. So this is 2.6, 2.61, 2.62, and then 3, 4, 5, 6, 7. 0.9962. This is our percentile, right? If you want to write this in percent, we're in the 99.62 percentile. And whenever you take tests, like on a college board, it'll tell you, on all the big official tests, it tells you you're in this percentile. That means that your number percentile of people who took that test did either worse than you or just as good as you. So 99.62 means 99.62% of the test takers, right, of this test did worse than you or just as good as you, leaving just what is it, what was this, 0.99.62, right? So that leaves 0.38 people, 0.38% that got more than you, right? So that's all percentile is. It's everyone who did worse than you or just as good as you, right? So if you're at 0.9962, that means you're in the, like, you did really well. I mean, compared to everyone else, you did really well on this test. Like basically nobody got higher than you. Everyone got either lower than you or as good as you. 99.62% of people got either worse than you or did as good as you. So that's what percentile means. That's z-score, and how to get percentile from z-score. And now is the last thing, 68, 95, 99.7% rule. So when you have a normal bell curve distribution, no, right? I said that at the bottom. Remember we talked about skewness, right? If it's not symmetrical. Well, if your distribution is symmetrical, right, then you're dealing with a bell curve, right? It's called a bell curve just, it looks like a bell, right? It's called a normal distribution. It goes up, comes down. It's symmetrical, So one standard deviation from the mean, you have 68% of your data, right? So imagine a curve, right? You draw a line in the middle. That's your mean. Now you draw one line, you draw a line to the right and line to the left. This is one standard deviation from the mean, right? So 34% of the data is one standard deviation above the mean, and 34% of the data is one standard deviation below the mean. Together, it gives you 68% from the mean, right? Now you extend that a little bit more, add one more line out for the second, on each side, add one more line out for the second standard deviation. This is 95% of your data. You go one more standard deviation out, 3 standard deviations from the mean, you have almost every data point that you're dealing with. 99.7% of your data will be within 3 standard deviations of the mean, right? And remember how we calculated standard deviation? We did variance and then just took the square root of variance. You got standard deviation, right? So this is just a rule. You're definitely going to see problems on it, multiple choice for sure. That'll be like, what percent of people are this standard deviations above or below the mean, right? And then you just have to remember this rule, and then you can do a little bit of algebra and you can tell, right? So remember how I split 68 into 34, right? Because 68% is one from the mean, but that means 34 on each side, right? So 34 above, 34 below, and then 95, the same thing, split it, you get above, below, 99.7, same thing. So that's a 68, 95, 99.7 rule. And yeah, that's everything you need to know for Unit 1 of AP Stats. And yeah, I have to give credits to SlidesGo because this was made thanks to them. And yeah, hope you liked the video.